Today's topic is haloalkanes. That is halogen derivatives of alkanes. In an alkane, if the hydrogens, one of the hydrogen is replaced by a halo group, any halogen, chlorine, bromine, any, then it's called a haloalkane. So halogen derivatives of alkanes are called haloalkanes, or common name is alkyl halide. Now the classifications are according to the number of haloatoms present. That is 1, 2, 3, mono, di, tri, and that. CH3Cl is a mono halogen derivative. CH2Cl2 is a dihalogen derivative. CHCl3 a trihalogen derivative, and CCl4 carbon tetrachloride is a polyhalo derivative. The other basis of classification is according to the nature of the carbon atom. This is attached to a primary carbon atom. Then CH3, CH, CH3, Cl. This is attached, the chloroatom is attached to a secondary group and can be a tertiary alkyl halide also. Next is the nomenclature. Nomenclature we have done in class 11. Anyway, nomenclature is, common name is alkyl halide, and the IUPAC name is haloalkane. Like this halogen group is named first and then the alkane group. And in this, this is the common naming system, this is the IUPAC naming system. Nature of the carbon and halogen bond. Now we all know that halogens are highly electronegative, much more electronegative than carbon. So this shared pair of electron is displaced towards the halogen atom. And in this, naturally a partial negative charge develops on the halogen atom and the partial positive charge on the carbon. So polarity, it is polar in nature. There is polarity in the molecule because of the electronegativity, high electronegativity of chlorine or fluorine bromine atom. Now as we move down the group, in the halogens, we see that the electronegativity is decreasing. As the electronegativity decreases, the polarity of the bond also decreases. Next, we will talk about the preparation process. Preparation is, first is from alkanes and halogens. This is, the mechanism is free radical substitution, free radical mechanism takes place. Alkanes, when in presence of sunlight or in presence of light or in heat, presence of heat, like 520 K to 670, it forms alkyl halides and one HCl molecule is. Now the problem is that in these various types of substitutions takes place. So it forms CH3Cl, it forms CH2, Cl2, it forms CHCl3 and CCl4. So 1, 2, 3, 4 compounds, in this case 4 compounds are present. So difficult to remove. In higher alkanes, suppose CH3, CH2, in higher alkanes under the same conditions, we get isomers. CH3, CH2, so various isomers are present, and it is very difficult to separate these isomers. Next is In the same alkanes and halogens, as we have done, chlorine and chlorination and bromination follows the same trend. But iodination and fluorination, iodination is as the reactivity is decreasing, the electronegativity is decreasing, and the iodination process is a reversible process. When a alkyl bromide or an alkyl fluoride or alkyl bromide on iodination, it forms HI. Sorry, this is from alkanes only, alkyl bromide. On iodination, it forms CH3I plus HI. Now, this is a reversible process. So, for converting HI into, we have to oxidize this HI into iodine. It is treated with, HI is treated with hydroiodic acid. And it forms iodine and H2O. If fluorination has to be done, then direct methods are not possible because fluorination is a very, very violent process. So in that case, Swartz reaction, it's called Swartz reaction. Metal fluorides are treated with the alkyl halides. Metal fluorides and alkyl halides react. And exchange of ions takes place. CH3Br is formed, CH3F is formed, and AgBr is heated with metal fluorides. Now this can be Ag2F2, it can be COF2, it can be antimony fluoride, or it can be arsenic fluoride also. This is called the Swartz reaction. So alkenes, now next is alkenes and hydrohalogens. Alkenes and hydrohalogens like HBr, HCl, etc. When any alkene is alkene, C double bond C, plus HBr, suppose. It forms, it's just addition reaction, and it forms if it is a symmetrical alkene, if it is symmetrical, then it takes place like this. But if it is an unsymmetrical alkene, suppose you have propene. In unsymmetrical alkenes, Markovnikov's rule is followed. What is Markovnikov's rule? Markovnikov's rule says that in an unsymmetrical alkene, the negative part of the addendum, this is the positive part, this is the negative part. So the negative part of the addendum adds up to the carbon, in the carbon-carbon double bond, carbon which possesses less number of hydrogen atoms. So the product is CH3, CH, Br, CH3. 2-bromo propane, that is the major product. And if, now there's another, this is Markovnikov's rule. Crash found out that if an organic peroxide is present, organic peroxide means benzoyl peroxide, C6H5CO, CH3, CH, double bond CH2, the same with HBr, if organic benzoyl peroxide. If an organic peroxide is present, then the reaction takes place contrary to the Markovnikov's rule. Means it will be product will be CH3, CH2, CH2Br. But it is found that this is called crash effect or peroxide effect, anti-Markovnikov's rule, sometimes also referred to as anti-Markovnikov's rule. But this crashes effect or peroxide effect we find only in case of HBr. In HCl, HI, it does not. Now from alcohols. Preparation of alkyl halides from alcohols. The first is we can treat it with a concentrated acid or gaseous state of it. If it is a primary alcohol, C2H5OH, this is called Groove's process. This is treated with HCl gas in presence of, heated in presence of anhydrous zinc chloride. So C2H5Cl and H2O is formed. This is usually the gaseous state. Now it can be a primary, this is primary alcohol. The Groove's process is applicable to secondary alcohol and to tertiary alcohol also, but the results will be a primary halide, secondary halide and tertiary halide. Tertiary alcohols are tertiary alcohol, CH3, 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 OH. This is a highly reactive species, so it does not need HCl. It can react with just plain simple HCl concentrated, and this is not needed. Anhydrous zinc chloride is not needed. So this will react with HCl and form CH3, C, CH3, CH3, Cl plus H2. After this Groove's process from HCl, preparation from C2H5OH, from the same C2H5OH only, by taking the chlorides of phosphorus. That is, can be PCl3 or PCl5, by taking the chlorides of phosphorus. C2H5OH phosphorus acid is formed. And C2H5OH with pentachloride also it will react to form C2H5Cl plus the oxychloride of phosphorus POCl3 plus HCl. Next is called the Darzen synthesis. Darzen synthesis. This is also from C2H5OH. So alcohol, ethyl alcohol and thionyl chloride. Ethyl alcohol and thionyl chloride is refluxed in pyridine. C2H5Cl, HCl and SO2. SO2. So C2H5Cl plus HCl plus SO2. Now we see that both of these are gaseous products. Because both are gaseous products, it is the most preferable method of preparation, because then almost in the pure form alkyl halide can be extracted. These two are gaseous product. So Darzin's process finds application.